students, we were discussing the CR circuit. Okay, the derivation I have done it. Okay, and each and every steps also I have explained it. If you just go to the other videos. Okay, and this is the circuit diagram of your CR circuit. I'm just explaining in short. This is your alternating voltage that is being applied to the circuit, due to which you are getting the flow of current, and is in this direction. The arrowhead is giving the direction in which it is flowing. Here we are having the capacitor, due to which you will have some drop, capacitive voltage drop, and you are having here also the R, the resistance. Here also will get some drop. So total, if you just combine, so net effective voltage that you will get, all you can see all those in your previous classes. Okay, in the previous videos. So students, I've just written your equation number 1. If you just remember while doing the derivation, this was your first equation, that is the alternating voltage equation, that is the alternating voltage applied to the circuit is this. Okay, now students, we have done the derivation, but now we will, in this part we will see that what conclusions we can draw from this derivations. Okay, so to draw the conclusions from this particular derivation, let us consider the two main equations. First equation is your this, that is the alternating voltage applied to the circuit. Equation number 1 it was. So another equation I will take, that is your this, I equals to I naught sine omega t plus theta, or V naught by Z sine omega t plus theta. That was your equation number 3. Okay, so I am taking this equation number 1 and in equation number 3. Alright, so now students, from these two equations we can conclude that your current part is leading the voltage by this theta, isn't it? Theta is the phase angle of this particular equation, isn't it? The current is leading your voltage, that is your V, by this theta. Alright, yes. So what we can write for this value of theta, students, I can write it as in this way, that your tan theta equals to what? Sine by cos. Okay, after this you just go back to derivation part. What was your value of sine theta? Your sine theta's value was 1 by omega c by z, isn't it? And what was your value of cos theta? It was your r by z. So it will now get reversed. Okay, and you will be left with 1 by omega c r. That is, your tan theta's value is becoming 1 by omega c r. Okay, so from this, students, I can able to calculate your value of theta, isn't it? Theta will be equal to tan inverse 1 by omega cr, isn't it? If you are finding the value of theta, you will be getting this tan inverse 1 by omega cr, isn't it? Now students, I will just explain this particular step. You can ask me that why I have taken this only tan theta in order to find out this theta, isn't it? Yes students, why I am taking this tan theta? Because in tan theta you have both the sin theta and cos theta, because tan theta's formula is sin by cos. So why I am taking this tan theta? So that I can imply both the sines and cos theta's value, because while doing the derivation, students, I have taken the sin theta's values as your 1 by omega c by z and your cos theta's values as z by r, sorry, r by z. So that's why, students, I have taken your tan theta, so that I can put both the sines and cos value. Understood? So yes, so finally I am getting the value of theta as tan inverse 1 by omega c r. Alright, so now students, this particular theta, I can put it one diagram. Okay, that is your phase relation diagram. You can see in the previous circuits also we have done in this way. Okay, so this is your V part and this is your VC part. VC means what? The capacitive voltage drop, and VR is what? Your resistive voltage drop, students. Now I will mark it in the circuit so that you can understand. Till this part you will have your VC, until this, from here to here you will have your VR, isn't it? That is the capacitive voltage that is being marked as VC, and this is your VR. Okay, that is the voltage drop due to the resistance. Okay, so here students I have drawn this. So yes, this is your phase relation. Okay, and this is your phase angle theta, so I have written it. So now students, we know that in case of a pure resistive circuit, okay, that means you are having in the pure resistive circuit what? V, R and I, isn't it? You have no other components, like here we are having C. Okay, so in purely resistive circuit, both your V and I are in the same phase. That means in that purely resistive circuit, the phase difference theta's values is equals to 0, isn't it? But now in this purely capacitive circuit, if you just go to the purely capacitive circuit, you will see that I always leads V by theta equals to 90 degree. That means your current leads the voltage by your phase angle theta, whose values is theta equals to 90 degree. Okay, in the case of purely resistive circuit. So, keeping all those concepts of this phase differences of both this purely resistive circuit and your purely capacitive circuit, okay, yes, so I'm just writing, students, whatever phase difference we are getting, phase difference equal to theta for purely resistive circuit. I'm writing here resistive circuit. Okay, let's write those values, and theta equals to 90 degree for purely capacitive circuit. I'm writing in short, students. Okay, okay, so keeping all these values of phase angle, that means both 0 degree for the resistive circuit and then theta equals to 90 degree for the capacitive circuit, we can see that CR circuit should lead the voltage by this. Alright,